everybody did the spiral? Anybody not turn in the spiral? If you didn't turn in the spiral, I will take it next class. But after that, you will see what will happen to you if it's not in next class. Yep. All right. So if I solve these equations, how do I solve this equation? How? Just tell me, describe how first, and then we'll do it. How do I find x? Do what?
First factor, and then set one equals 0.
Okay. She's like, factor it, and then we're going to set each one of these factors equal to 0, because the only way to get 0 is if this was 0, or that one was 0, right? Because anything times 0 is 0. So let's see. Remember how to factor these guys. I call these type 3s, where it's a trinomial, my leading coefficient is 1. The only way to get x squared is x times x. Now I need two numbers, multiply 3, add to 4.
1 and 3.
1 and 3. Okay, so let's set this one equal to 0, and let's set this one equal to 0. So what's x? -1 or -3. Okay, what am I going to do with this guy? Same kind of idea, except let's see, to factor it, I'm going to put everything on one side of my equation. Now, how do I get these? How do I get there? Yeah, I moved everything over here. I could have moved the x here, and I get a negative x squared. I don't like working with a negative x squared. It makes the problem a lot harder. So I try to keep this positive if I can and keep it a pure type 3, where it's a trinomial leading coefficient 1. It's kind of a special one. You might have noticed it's a special one, but let's see. Two numbers that multiply to positive 3 but add to negative 6. Negative 3 and negative 3. So this is a perfect square trinomial. It's x minus 3 squared. What's x? 3, right? Oh, yeah. This one looks horrible. Let's see what we can do here. 21x minus, well, 21 times 4, 84, equals 2x times x is 2x squared. 2x times 2 is 4x. 4x minus 7x is minus 3x. Minus 7 times a positive 2. And let's see if we can get everything on one side of the equal. 2x squared. If I subtract the 21x, what do I get? Minus 24x. Now I'm going to add 84 plus 70 equals 0. So combining the like terms, putting it all on one side of the equal. Now this looks like a type 5. A type 5 is when you have a non-1, except it's not really. What could I do? Divide everything by 2 on both sides, right? So x squared minus 12x plus 35 equals 0 over 2 is still 0. So we made it a simpler problem by factoring out the common factor first. And then what do I get? Can I do what? You could, but that makes it really hard. So if you can factor, do that first. Right? Take out a greatest common factor. You always look for that first. Two numbers that add to 35 and subtract to negative 12. Negative 7, negative 5. So what do I get here? X equals 7 and 5. For those guys? What else do I have here? Okay, now this one is a true type 5. I can't reduce, right? So then how do I do this one? How do I do it? You do 2 times negative 3, which is negative 6, and you can make this all short if you want, and it has to add to negative 5. So I need two numbers, multiply to negative 6 and add to negative 5, yeah? Negative 6 and 1. Looks like that works. So what do I do with that? I'm going to split up the middle term. 2x squared minus 6x plus an x minus 3 equals 0. Correct? We all know what I'm doing? Okay. Then I group, because now it's a type 4. And I say, do I have any common factors here? I do have 2x, right? And then what comes out? X minus 3 plus x minus 3 equals 0. I like that. I see a common polynomial here that I can take out, kind of factoring this guy out now. And what's left? 2x plus 1 equals 0. So what is x? X can be 3. 2x plus 1 equals 0 when x equals negative a half. You would just, if you don't see that, just solve this and you'll get x equals negative a half. You could use guess and check with this one. I did this one with guess and check. And guess and check is, can you figure out how you can get there? The only way to get to 2x squared is a 2x and an x. The only way to get a 3 is a 3 and a 1. So would the 3 and the 1 go here? Or would the 3 and the 1 go here? And just kind of multiply and see what works. It works better when you have prime numbers, either here or here. Otherwise, you get a lot of computation that gets hard. But this is fine. Going this way, absolutely fine. Now, the other way to handle these, if your factoring skill is not so great, use the quadratic formula. I'll use the quadratic formula on this one, just to demonstrate in case we forgot how to do it. Right? The factories are not working out. Maybe this one's hard to do. Right? Ax squared plus bx plus c. So your a is 1, your b is 4, and your c is 3. You want negative b is 4, plus or minus the square root of b squared, 4 times 4, minus 4 times 1 times 3, all over 2 times 1. And you get negative 4 plus or minus square root of 4 over 2, which is negative 4 plus or minus the square root of 4 is 2 over 2. So let's look at the plus side of it. I could have negative 4 plus 2 over 2, which is what, negative 1? Negative 4 plus 2 is negative 2 over 2. Or I could have negative 4 minus 2 over 2. It's negative 6 over 2, which is negative 3. Is that the same thing we got up here? Sure is. So sometimes we can't factor. Sometimes the factoring just doesn't work. You will use a quadratic formula. Or I guess you could compute the square, whichever is your favorite. Sometimes you just forget, or I can't figure out what two numbers multiply that are similar to that. Use the quadratic formula. You remember it? Who remembers it? I only see like 4 people with their hands up. You don't remember quadratic formula? All right, so what do we need that for? I wonder why. I guess we'll find out soon. Segments in a circle. Now this one's really similar. We've kind of seen this before when we were looking for arc measures. Now an arc measure and an arc length are kind of different things. Now when two chords intersect in a circle, you get these two segments here. I see segment AE, I see segment EB, EC, and DE. They're segments of the chord. And our first theorem is, I think that's right here, if they intersect inside a circle, this piece, the AE times EB, so this piece times this piece, equals that piece times that piece. So this was a 5, a good one. And this was a 6, and this was a 2, and this was a 15. This times this equals that times that, does it? Yes, right? That's how it works. Okay, that's a theorem we got. Another theorem, okay, is if you have secants involved in tangents. So a secant segment is, here's an external segment, that is a secant. The segment, the little piece of it's right here, and this is a piece of a tangent. Okay, and they're external, they're outside the circle. So here's this theorem, you ready? You gotta really pay close attention to this one. Okay, this piece, this little red piece, EA times the whole thing, EB. So EA times whole thing, this whole piece, equals the other little segment outside the circle times whole thing, EB. So little piece times whole thing equals little piece times whole thing. Anybody have trouble seeing that? Little piece times whole thing, little piece times whole thing. You could also have a tangent, and it's actually the same theorem, kind of. This one is, see this little red piece, the little outside piece times whole thing equals that piece times that piece. So the little piece outside times the big piece, this piece times big piece, equals that little tangent piece. Take that value and square it, multiply times itself. So easy to say. let's see if it's easy or not to do. So let's see, if I have two chords, okay, it's this piece times that piece equals this piece times that piece. AE times EB equals DE times AC. That may be a little bit easier. This one, two secants, this piece times whole thing equals that piece times whole thing. External times whole thing. External times whole thing. This one is very similar to that one. External times whole thing equals tangent piece squared. So we do have some examples here. So this piece times this piece equals that piece times that piece. So hopefully you're with me. We're bottom-ish of the page, middle. Example A. So 12 times x, this piece times this piece, equals 8 times 6. That piece times that piece. 12x equals 48. So x is 4. Okay, looking at one with two secants. So be careful with these. Be really careful. You know what you're tempted to do? X times 4 equals 2 times 4. Don't do that. Don't. Don't. Stop and think. So x times, what's this whole piece? X plus 4, right? We're adding those pieces together. We're using little segment addition. Equals 2 times, what's the whole piece? 6. Anybody not see where that's coming from? This is kind of the critical mass here. This times whole piece equals that times whole piece. Well, what do I have here? I've got x squared plus 4x equals 12. Well, now I have to solve this. And is it making sense, all the factoring we've been doing? Now it's making sense, right? You guys look so now, isn't it nice that you're using the factoring? There's a reason to learn how to do it. All right, I need two numbers that multiply to negative 12, but are going to add to 4. Multiply negative 12, but add to 4. What do we get? Negative 6 and 2. We're close. When I add them, though, I'm going to get negative 4. So what do I want? Swap them around. Plus 6 minus 2. Check it, right? That's minus 2x plus 6x gives me the 4x. So what's x? So x is negative 6 and 2. That's your answer.
No.
Why not?
Not negative 4. Can't have a negative 4.
Right. Can x be negative 6? Can this line be negative 6 units long? So make sure you do this. You should write the words reject here. And why is that kind of important? It's showing, you know what, I considered the answers. This one doesn't make sense. I'm going to reject it. 2 I'm looking at. 2 does work. And when you think about it, this one's kind of a silly one. 2, I mean, yeah, they're like nice congruent pieces here. So you have to consider both answers. All right, let's review this little theorem here. This says that 5 times what? Careful, careful, careful. 5 times what? 15. Whole piece equals that guy times itself. Well, 5 times 15, last time I checked, I think that's 75. I'm going to turn it around just like looking at it this way. So if x squared is 75, what's x? Careful now.
5 squared. That's 3.
What, plus or minus the square root of 75. Why am I doing plus or minus? Because a negative times a negative will also get me here. You have to consider both. And let's reduce that a little bit. See, that's what he started doing. Can we simplify this into simplest radical form? Yeah. Because 25 times 3 is 75. So I've got the plus version and I've got the minus version. And let's consider both of them. Depends. So this one it doesn't say. If it doesn't say, I usually go here. This is the exact answer, right? Exact. It doesn't say to the nearest tenth. If they tell me to round it, then I will probably, if it doesn't say, in general, go to simplest radical form. If it says go to the nearest tenth, then just plug it in your calculator. I'm going to reject this guy. Why am I rejecting the negative? Yeah? Can I have a negative length? Now, don't out of hand reject negatives. You really do have to think about it. Sometimes they work. If this was some square value, I don't know. Sometimes they do work. So don't reject them just like that. What do you guys think? questions? The things to look out for, make sure when you're doing ones like this piece times whole piece. This times whole piece. Most likely mistake you're going to do is just do an x times 4 equals 2 times 4. Don't do it. Don't be fooled. All right, let's try the U tries on the bottom here. Here. E. Okay. So, it's like a circle. This times this equals that times that. So what am I getting here? I'll put it up here a little bit more. X plus 1 times x plus 5 equals x plus 2 times x plus 3. Have you set it up the same way? Yeah? Okay. So now let's multiply out. Use our FOIL. Well, that's x squared. 5x plus 1x, that's 6x, plus 1 times 5 equals x squared, plus 3x plus 2x. 5x plus 2 times 3 is 6. Hopefully I did that part right. With me so far. I love when I see the same thing on both sides, because you know what I can do? I can subtract x squared from both sides. Basically, they cancel each other out. Isn't that nice? They're gone. All right, now I can subtract that 5x here. That gives me x, and I can subtract the 5 on that side. I'm getting x equals 1. And then if you want to find AB and you want to find CD, you got to like plug in the number. So 1 plus 2, that's a 3, that's a 4, so AB is 7. 1 plus 1, that one's 2, that one's 6, 2 plus 6 is 8. So that's a good one. It's nice when they cancel out. When they're easy. Now I got to do Natalie's. I don't know if I get away with that with Natalie's, do I? I don't think so. All right, let's see. So with this one, x plus 1. Now be careful. It's whole thing. Don't just say this piece. Whole thing. So I have to add them. X plus x is 2x plus 4, right? Add these together, you get 2x plus 4. And that's going to equal x plus 2, the outside piece, times whole thing. Whole thing is x plus 2 plus 2, x plus 4. All right, did you set it up the same? Okay, good. So let's see, 2x squared plus 4x plus 2x, 6x plus 4 equals x squared, 6x plus 8. We match so far. Okay. I'm going to combine everything into one spot. So I'm going to subtract the x squared over. Ooh, that's nice. My 6x's cancel out. And then I have subtract the 8. It's like a minus 4 equals 0. So let's see. X squared equals 4. So what's x? Plus or minus 2. And now let me check to see if I should reject one or not of them. Well, the negative's always a little suspicious. If I put a negative 2 in, this negative 2 plus 2 makes this a 0 length. This negative 2 would make this a negative length. So I'm going to reject the negative 2. And I'm going to keep the positive 2, because I think that one will not mess anything up. So it makes that one 4, 2 plus 1 is 3, 2 plus 3 is 5. And now they want me to find ED. Looks like it's 8. And ED looks like it's 6. So yeah, a little fancy footwork. It's a good one. Oh, that's a lot of algebra. I thought this was geometry. Alright, so outside piece times whole thing. 6 times 6 plus 8 equals outside piece times whole thing. Okay, 6 times 14. You found it? Right, be careful. We're adding. Segment addition, right? Add those two pieces together. Yes? D? Well, let's see. This times whole thing. So if this is x, and I see my little congruent side, what's this one? X. So this x times the whole thing, what's x plus x? 2x equals that piece squared. So x times 2x, 2x squared equals 64. Divide by 2, divide by 2. X squared equals 32, which means x equals plus or minus the square root of 32. I can't have a negative length, so I'm going to reject the negative. And so it is positive around 32, but I think I can reduce this guy. 32 is 16 times 2, is that right? piece times whole thing, outside piece times whole thing. But you get some fancy algebra sometimes. So it's a good test of how our algebra is going. Any remaining questions? No, we don't want to see you anymore. All right, so that was part one. That was part one of what we're talking about today. And this one, I think it's a little bit more straightforward. Circumference, right? You guys know circumference. What's the circumference of a circle? Do you remember that formula? What's it? 2 pi r. R is the radius, right? So really the diameter times pi is your circumference. So it's the distance around a circle, like perimeter, but for a circle. 2 pi r, or pi times d. D diameter, r is the radius. Example. Find the circumference of a circle with radius 9. Now there's two ways to answer this question. Pi is irrational, isn't it? An irrational number. So I'm never going to get like the exact number if I multiply by pi. However, if I leave an answer in terms of pi, you consider that the exact answer. So for example, if the radius is 9, c equals 2 pi r, correct? So c equals 2 pi times 9. I can, again, 2 times 9, combine those. C equals 18 pi. Correct? And that's it. That's your exact answer. You just stop. Leave it in terms of pi. And you should put your units in. They didn't give me units. I'm just writing units. Now, if they want an estimated answer, this is when they say round to the nearest 10 or round to the nearest 100. That's when you pull up the calculator and say, well, I don't know what 18 times pi is. I think that's approximately. But 18 times, if you press your second button, and I think it's over the little circumflex, there's a pi, and you hit enter. Let's round to the nearest, I don't know, I'm going to go to the 100. 56 point, what's the nearest 100? Thank you. 56.55 units. This is an estimate, right? I had to round. So exact answer is in terms of pi. An estimate is when you kind of multiply it out and then round it. So example B, find the radius of a circle with circumference 26. So now you're kind of working a little bit backwards. So C equals 2 pi r. This time I know C. So 26 equals 2 pi r. I want to find r. So I divide by 2 pi. And let's see, I can reduce the 26 into 2, right? So r equals, reduce those guys, 13 over pi. That's my exact answer. If it says exact answer or it doesn't say around, whatever, there it is. 13 over pi. Now if I want an estimated answer to the nearest 10th, to the nearest 100th, then I take my calculator. So 13 divided by pi. Now to the nearest 100th, what am I going to get? 4.14. And again, don't forget units, even when they don't say it, I try to remember it. That many units. They didn't tell me what they are. Yeah, easy. Did I read everything? Okay, now here's we have to make a real important distinction here. We've looked at arc measure. Arc measure is degrees, right? Arc measure, like in this example, if this thing was 60 degrees, the arc measure would be 60 degrees. But that's not the length. It's just measuring how far did you open up this angle. Now I'm looking at arc length. That's like if I had like a string and I made it in a circle, and I cut here and I cut here, how long is that string? What? Well, I don't know. I need more information. True. It's not 60. 60 is how far did you open this angle. Arc length is, it'll be some units, yards, feet, inches, centimeters. If you have a piece of string, you cut a little piece off, how long is that? It's actually a piece of your circumference. A piece of your circumference. That's arc length. We've got a whole big formula here. The best way to kind of remember it, I think, is to say, I know what circumference is, right? 2 pi r. Right? That will give me the whole circle. I don't want the whole circle anymore. I want just a fraction of that circle. So let's go back to the example. It's a little hard to read here. Let's go back and say that I know this angle is 60 degrees. I opened it up 60 degrees. Well, what fraction of a circle do I have here? Well, what's the whole circle? If this is 60, what would be all the way around? 360, right? All the way around is 360 degrees. The circle is yeah. So what fraction? I have 60, 360x of a circle, and I want that fraction of the circumference. Yeah, or 1/6, and then you go, you have and reduce and all those good things. So this is so confusing. They put it in terms of the central angle, which is fine, because of the arc, because they're the same thing. I kind of prefer, this is from your book, I kind of prefer to look at the angle. And arc length, traditionally we call that S. S equals C for central angle over 360 times your circumference. So make a fraction of your circle, multiply by circumference, you get the length of just that little piece. Does that make sense or not make sense? Can't tell if that makes sense. Who says, yeah, C is the central angle measure. Or you could use arc length as well. Because aren't they equal? Huh? S is arc length. Traditionally, that's what we call it. Why? I don't know. We just do. So S equals C over 360 times 2 pi r. You just think about what you're doing. I'm getting a piece of the circumference. So let me start with your circumference, and I'm taking a fraction of it. And since I have 360 degrees in a circle, that's the fraction I'm taking of it. So in this case, if r was 2, making it up, you can reduce here. Well, that 6 becomes a 6. That would be a 2. I can reduce that guy and get a 3. Multiply across, I'm getting 2 pi over 3 units. That would be the exact arc length. If you want an estimate, 2 times pi in your calculator, then divide by 3. So, what is all this? I think this is, yeah. So, like, if you have a circle here, just to kind of belabor the point here, if this was 90 degrees, what fraction of a circle do I have here? 1/4 of it. Well, how would you get that? That's 90 over 360. Right? And we can see it's 1/4 because we can just kind of see the picture. But it's 1/4 the circumference. But they're always not so nice, 90 degrees where you can see it. So take your angle and put it over 360. And again, I'm going to say it again. Arc length and arc measure are different things. When you say the measure of an arc, I'm looking for the degree measure. If I know the central angle, it's going to be equal. If I know an inscribed angle, it's double that, right? Arc length is a piece of circumference. It's going to be inches, centimeters, meters, whatever units you have. It's like you cut a piece of string, and you just took a little section of it. So let's see if we can do a couple of examples here. Find the length of AB. So we're going to do the exact and we're going to do the estimated. So let's see. The length. Length is my key that I want a piece of the circumference. Circumference is 2 pi r. Well, what's my r? Looks like it's 5. Now, do I want the entire thing? No. I only want 150 over 360ths of it. So you set it up first. Now, I always reduce. If I see a 0, right, those go away. What else do I know? 15 is a factor of 360, I believe. I'm trying to see what it is, because I can't remember. I think it's 12.
15 is a factor of 50.
Yeah, I already reduced that. So I'm going to take out 3. That becomes a 5. That becomes a 12. But now I can reduce this way, right? So that becomes a 6. So 5 times 5 is 25 pi over 6. I'm getting 25 pi over 6. That's the exact answer right here. Exactly. Now if you want the estimated answer, I go to my trusty old calculator. 25 times pi, and then divide by 6, divide by 6. If it doesn't say how to round, I usually go to the nearest hundred, so 13.09. Okay, don't forget your units. These are in units. Right? Circumference is just 50 units. Yeah.
So you divided the 12 by the 2 and pi.
Yeah, I did a little reduction. Yeah, cross reduction, all kinds of reduction. We used to be real good at it back in the day because we didn't have calculators. No, it's not negative. I don't see any negatives. I couldn't be negative, right? It's a length. It's not going to be negative. We're getting negative, there's a mistake. Okay. Sometimes they go the other way. So here they're giving me the length. Here's the arc length. The length of AD, not the measure, the length, is 18.84 meters. And they want me to find the measure, the degrees. So that makes me think of this. Because the degrees and this degree and central angle are the same. So I want those degrees. So what don't I know? I don't know what fraction of a circle I have. But I think I know everything else. 2 pi r, r is 9, and I know what I'm supposed to get. And now I gotta solve this. Looks like I could do some reduction there. Again, do cross reduction, it makes it a little bit easier. That's a 180. I can reduce that guy, right? 9, what's that, 20? So what am I having here? I've got x over 20 times pi equals 18.84. Yes? Question? Uh-huh. Now remember, arc measure and central angle are the same. So you can work with our AD. I'm somehow more comfortable just with the angle. But they're equivalent. So I kind of just pulled it down here. But you could say mark everything. You can mark x. You could have done that. They're equivalent. Alright, so now if I want x by itself, what am I going to do? I'm going to multiply by 20 over pi, right? To cancel these guys out. So I don't know what that is. 18.84 times 20 is 376.8 over pi. Usually we don't ask for an exact answer here. Because, whoops, it's x times pi over 20, right? I want x by itself. So you multiply by that reciprocal, 20 over pi, 20 over pi. Back to solving for x. And then divide that by pi to get the approximate answer. 119.94. What? Degrees, right? Yes. What I did was I did 18.84 times 20, gave me this, and it's still over pi. So again, if they say exact answer, usually something this wacky, we're probably just going to go through the estimate. It's approximately 120 degrees in here, basically what it says. So you have to kind of look for what it's asking for, where's your x, and kind of search around for it. So questions? I've got a couple of U-tries here. Let's just take a couple of minutes and work the U-tries. Let's talk about, now the first one hopefully we can do. Now write out some of you were trying to do stuff in your head. This is the circumference formula, right? We can also write it equals pi times diameter. So circumference equals pi times 16. By convention, we put the 16 in front of the pi. There's your exact answer, right? Multiply by pi to get this. This one I kind of did here. Write out the equation. Write in what you know. Solve for what you don't know. Questions on B. All right, now C. I have a little piece. I'm looking for a little piece of the circumference. I know how to find the entire circumference. It's 2 pi r. That would give me the whole circumference. I want the whole circumference. I just want 40/360ths of it. So you set this guy up. Now it's a reduction thing, and this is how big your arithmetic is, right? So the zeros go, looks like I can make that a 9. The 6 and the 9 reduce. They have a common factor of 3. And now I multiply across. I've got 4 pi over 3. There's my exact answer. And then I say 4 times pi, put it in your calculator, hit enter, then divide by 3. You should get to the nearest hundredth that one. This one now, they're not giving you the radius, they're giving you the actual measure. So let's see. The length rather, I should say measure. 260 over 360, right? Times 2 pi r, I don't know r, so I'm just going to leave an r. And what should I get? 81.64. Okay, questions where this is coming from? Questions where I just got that? Yeah. It's the length. you were to like, you know, cut this, if this was a string, and if you were to cut this, make it straight, you would measure 81.64 inches.
So it's like from A to B.
All the way around. Yeah, all the way around. Okay, now it wants the circumference. You know where the circumference is? It's right here. 2 pi r. So I'm actually solving for this. So I'm going to reduce this guy a little bit just to make it easier. That goes, I can see 2, 13, what, 18? All right. Okay, so how do I solve for 2 pi r? Multiply by the reciprocal of that guy. 18 over 13. Because won't that cancel it out and I'm left with 2 pi r? Well, whatever I do to one side of the equation, I do to the other. So I don't have to go down to r. I don't want r. I want 2 pi r. So in my calculator, I did 81.64 times 18, and then I divided by 13. Hopefully, that's what comes up when you do it. Is that what you get? Maybe? Yes.
How do you get the between the 40?
I just reduced this. 26 and 36, I divided by 2, and I hope I did it right. Want to do it wrong? You want to multiply by 36 over 26, you can do that too. It's just, this is how I'm trained. Reduce. Smaller numbers are less likely to make a mistake. Is that what we get if you multiply this out? Did we get that? All right, there's a couple of others over here. Did anybody get to this guy? Well, it's the same kind of idea. This one says find the radius. So I have 45/360ths of this circle times 2 pi r equals what? That length of 1.57 feet. So now I do have to solve for r. It's not asking for the circumference, it's asking for r. Oh, I know, 45 does go into 360. 8 times? I think it's 8 times. Okay. And then, I can reduce the 2 and the 8 is 4. So if I was to just rewrite it so I can see what I've got here. Right, I think I reduced enough so that I'm looking at this. I want r. So what do I multiply by? 4 over pi. Because I did a whole bunch of reducing. Reduce. I lost my train of thought here. Right, because I had a 2 and I had an 8. So that became a 1. Divide that by 2, you get a 4. Cross reduction. So I'm multiplying by 4 over pi. So in your calculator, r is going to be 1.57 times 4. Divide by pi. I hope we get approximately 2 feet. I hope we do. That's what I got. Playing with these little guys here. And then this one with the revolutions. Skateboard has a diameter. You got the wheel. This is a skateboard wheel. I hope that's what this is. Has a diameter of 56 millimeters. That's this whole thing. How many revolutions does it make if you're going 3 meters? So you're like turning. Well, can we find, that's like unrolling it. So what is the circumference? Or pi d of this guy? Well, it's 56 pi millimeters. When I put that in my calculator, what did I get? I don't know. 175.9 something? Somebody check me. I can't read my own writing. Well, a couple of ways to approach this. One is millimeters, one is meters. Somebody's got to change this. You want to go to meters or millimeters? Which way do you want to go? Millimeters? How do I turn 3 meters into millimeters? Well, how many times? Let's see. I got to go back to, what do we got? Decimeters, centimeters, millimeters, right? Is it 3,000? Yeah. And then how many of these can I fit in there? I don't know. Let's see. I think we can just do that. What did I get? 17-ish? Approximately 17 revolutions. What? 1.57? All right, wow. I guess it's harder than I thought. If you just remember, it's circumference and a fraction of the circumference. Because the next little thing here, it's a very, very similar idea. It's area of a circle is pi r squared. Same thing. How do you find the exact answer? And I'm just going to speed it up a little bit here. 2.5 squared times pi, figure out what 2.5 squared is, 6.25. And this time it's, units are squared, square centimeters. That's a unit for area. Multiply that by pi, you get an exact answer. I got 19.63 for those. Find the diameter of a circle. So pi r squared equals this number. R squared equals that. So r, we're always going to take the positive of that number because I don't want a negative radius. This will give me a radius. When you put this in your calculator, you then multiply it by 2 to get the diameter. So I just want to get to the business here because we're running a little low on time here. What's the main event here? Sectors. It's like a piece of pizza. We want to find the area of that piece of pizza. And it's the exact same thing. It's complicated looking. You find this angle, column theta, theta over 360. This time I want a fraction of the area. And that's how you get a sector. So same kind of idea as the other one. And I think I'm going to pause here.